Welcome back to the deep dive. We are trading our desk chairs for the captain's seat today. We're plunging into the world of, well, pretty high-end marine safety technology. Got some fascinating material here. It's all centered around what the specialists we looked at are calling the most critical, high-impact safety upgrade a vessel can possibly carry.
Yeah, it's quite a statement they're making.
It is. The core idea, and this comes from pros who outfit everything from search and rescue boats to, massive super yachts, is this. The Flir Thermal Camera is the single most valuable safety and awareness system a captain can add. That's a huge claim, right? Especially when you think about all the other gear radar, AIS, chart plotters.
It is absolutely a bold claim, and our deep dive today is really focused on, justifying that. Why thermal imaging specifically, and how does it actually change your decision-making when things get tricky out there?
Where do we start?
It starts with understanding what it fundamentally sees.
Yeah.
Because it's different from everything else. We're not dealing with radar, bouncing radio waves off things. And it's not spotlights either, which obviously need light in your eyes to work. Thermal cameras, they operate totally differently. They're in the infrared spectrum.
Infrared. Oh,
they passively detect heat. The energy signatures coming off everything around the boat.
So basically, it's like giving the captain heat vision, a temperature map of whatever they're looking at.
Precisely. Yeah, you could put it that way. It turns what looks like a cold, dark ocean into a visible field of heat signatures. That means you can see things like a lobster pot that's barely visible, or maybe a distant boat without its lights on, or, critically, a person's body heat. It shows up as a clear visual target, even if it's pitch black or foggy.
So you get this live picture of heat, letting captains see where, as the sources put it, light simply doesn't exist.
Exactly. Maintaining that situational clarity.
Okay, let's unpack that a bit, thinking about the reality of being out on the water. Because, the sea can be relentlessly unpredictable, right? We know even the best captain has limits. Your eyes fail you at night. Radar, well, it has its own blind spots.
Absolutely.
And the sources we looked at suggest thermal imaging tackles two key failure points at the same time. First, finding those obstacles that radar or your eyes just won't pick up easily, things that don't reflect radio waves or light well. And second, instantly locating really high priority targets, people or other boats when you can't see a thing, like total darkness, heavy rain, thick fog.
That's the core of it. On a big boat, maybe moving fast, your reaction time is everything. We're talking seconds. And those seconds can mean the difference between, avoiding disaster or not. If we look at the real-world threats the sources mentioned, thermal imaging picks up collision risks that other systems often just miss.
Like what specifically?
Well, think about semi-submerged hazards.
Yeah.
Stuff that's barely breaking the surface. Maybe a big waterlogged log or a drifting fishing net, sometimes even a shipping container that's fallen overboard, floating just maybe inches under the water. Radar might miss those completely or just show it as, sea clutter, background noise.
Right.
But these things, they hold heat differently than the water around them. So the thermal camera sees the shape of that object against the cooler background. And it sees it long before your eyes could, or maybe even before radar gets a solid return.
That sounds like the difference between a quick turn and potentially holing your boat.
Absolutely. Catastrophic damage, potentially. And then there are other boats, vessel hazards. Lots of small craft out there, maybe fishing boats, tenders.
Yeah.
Sometimes they run without proper nav lights. Or maybe they're just lost in the swell. If they don't have AIs broadcasting their position, they're effectively invisible at night. But thermal vision makes them pop. Their engine heat, the body heat from the crew,
Okay.
It makes them stand out instantly.
I guess this applies to navigation markers too then. Like, trying to find an unlit buoy in a channel in bad weather must be nerve-wracking.
Oh, definitely. You're usually relying on your chart plotter position and, frankly, a bit of guesswork. An unlit buoy or maybe a temporary race marker, it can be invisible to radar until you're almost on top of it. But the material itself, maybe it's warmed up a bit by the sun earlier or just naturally radiates heat differently than the water. It shows up clearly on the thermal display, gives you that critical time to adjust course.
But where this tech really seems to earn that single most valuable title, at least reading through this, is in emergencies. The man-overboard scenario.
Yeah, this is probably the most powerful example, the definitive one. In an emergency like that, MOB, every single second counts. Delays drastically reduce the chance of survival. Flir completely changes the game here. Goes from this frantic search, waving spotlights around, hoping to catch a glimpse.
Which often just reflects off the waves and blinds everyone.
Exactly. Instead, it becomes an immediate location effort. You're not just scanning the dark water for a tiny head bobbing up and down.
Yeah.
You're seeing a bright white, unmistakable thermal signature against the cold black water the second they go in.
Wow, that human body heat.
It's unmistakable, and it cuts right through fog, rain, darkness. Compare that to hoping radar picks up something so small, or using that spotlight, being able to spot a person instantly, maybe hundreds of meters away. That's why they call it a genuine lifesaver. It gives you a level of certainty and near zero visibility that, honestly, GPS and radar alone just can't touch.
Yeah, that definitely shifts it from panic to, hopefully, a confident rescue plan. Okay, so beyond just spotting threats, let's look at the day-to-day operational side. What does having this new sense, as some captains called it, actually look like when you're just navigating?
Well, the captains interviewed talked a lot about how it changes high-stress maneuvers. Think about coming into a tricky inlet late at night. You're trying to spot the jetties, the breakwaters, maybe some unlit channel markers. Doing that just with radar and charts, well, it's stressful. Requires intense concentration.
I can imagine.
With thermal, a lot of that stress just evaporates. You get visual clarity. You can clearly see the shape of the shoreline. You can see the heat coming off a concrete jetty, the profile of a breakwater, long before you normally see it or get a clear radar picture. It shifts navigation from sort of high-stakes guessing to factual confirmation.
Okay, so seeing the big structures, what else?
Another really common, crucial use is night docking and also tender operations. Trying to maneuver, say, a 150-foot yacht into a packed marina at 2 a.m. is stressful anyway. Add darkness and the risk of a small unlit dinghy crossing your path, or maybe a dockhand standing somewhere you can't see. It's real. Flir's detail, that clarity it provides, just makes those close quarters moves safer, quicker, and way less taxing on the captain and crew.
That's interesting. So it's not just about avoiding the big disasters offshore. It's also about precision and confidence in really tight spots. Captains really feel like they've got a whole new sense.
They really do. It's immediate. It's passive sight. You just look. And the tech has evolved, too. It's not like you have this extra separate screen you have to keep glancing over at. These systems now integrate pretty seamlessly with all the major navigation suites,
Right.
Raymarine, Garmin, Furuno. So you get unified control, often right on your main bridge displays.
Right. Okay. That integration point brings up a question, though, and it's a challenge we should probably address. If thermal imaging is so vital, surely others are catching up. Why is Flir presented as, like, the top dog, trusted by the Coast Guard, naval operations? They call it defense-level engineering. Why is that investment, which can be pretty significant, worth it compared to maybe cheaper thermal options out there?
That is the critical question, isn't it? If you're the captain, you need gear that performs flawlessly, especially in the absolute worst conditions. The difference between a high-end system like Flir and, say, a generic thermal camera isn't really about the basic idea of seeing heat. It's about the quality and reliability of that image when you absolutely need it most.
Quality and reliability, how so?
We're talking about basically 3 key technical advantages they highlighted: stabilization, optics, and just sheer durability. Let's start with stabilization. Imagine a generic thermal camera bolted way up high on a mast. When the boat's rolling and pitching in, say, a 6-foot swell, that camera's view is going to be shaking all over the place, often totally unusable footage.
Okay, makes sense.
Flir units use sophisticated gyro-stabilization. It's specifically designed to counteract that constant, often erratic movement of the vessel at sea.
So Flir basically locks the picture down, keeps it steady. The captain gets a stable horizon reference image of whatever they're looking at, even if the boat's bouncing around.
Exactly. That stability is crucial. It ensures that critical target, maybe that floating container or that person in the water, stays visible and trackable. It lets the captain make a quick, decisive move based on a clear image. Without stabilization, you might as well be looking at, well, noise, static.
Okay, stabilization is huge. What about the parts actually doing the seeing, the optics and sensors?
Right, that's the second piece. Flir uses precision optics, lenses specifically engineered for the harsh, saltwater marine environment. They're housed in really robust anti-corrosion casings, and the sensors themselves are high resolution. They're carefully calibrated to pick up very subtle heat differences and show clear shapes of objects even hundreds of meters away. A cheaper alternative might cut corners here. Lower resolution, maybe inconsistent performance, especially if the outside temperature changes a lot or the lens fogs up.
And durability.
That's the third leg. Think about it. You're trusting this camera to potentially spot debris at night that could literally sink your vessel. It has to be incredibly rugged, properly marine grade, built to withstand years of spray, sun, vibration, temperature swings. It's not just about putting a regular camera in a slightly tougher box. The sources stress that the investment is justified because when that generic alternative potentially fails, maybe in a storm, or when visibility is pea soup thick, the defense-level engineering behind Flir is designed to keep delivering that critical image.
Okay, that makes the technical case pretty clear. Let's zoom out for a moment, though. Beyond the tech specs, captains also mentioned this idea of the luxury of certainty. What did they mean by that? It sounds more psychological.
It is, but it's incredibly important on board. It moves beyond just the hardware and into things like command presence, peace of mind. A Flir camera isn't just another tool for the crew to use. It becomes a sort of guardian for everyone on the yacht. Think about it from the guest perspective. If you're in a fast boat, crossing open water at night, knowing the captain can effectively see through the darkness and fog in real time, that provides immense reassurance.
Right. It must change the whole feeling on board.
Absolutely. Uncertainty breeds stress, kind of anxiety among the crew, but clear situational awareness, that breeds confidence, competence. Having this technology visibly present, knowing it's working, it actually elevates the captain's command authority. People trust the decisions more. So the overall impact is, yes, enhanced safety, but also proactive awareness and ultimately just more confident decision-making. That allows everyone, guests and crew, to relax a bit more and trust the journey.
That makes sense. It transforms uncertainty into clarity.
It's profound, really. The sources said once a captain navigates, say, a tricky channel in dense fog using thermal, they realized they were essentially driving half blind before. They just won't willingly go back to operating without it.
Okay, but there's a final piece here we need to touch on. We talked about the complex hardware, but all this amazing capability depends on one last critical thing, getting it installed correctly. We heard that you can buy the best camera on the market, but if it's put in wrong, you've basically wasted your money.
That is absolutely spot on. A camera that's, say, mounted at the wrong angle, or not calibrated properly, or maybe it's not fully networked into the main bridge systems, its performance is going to be severely limited. For instance, if the mounting angle doesn't give the optimal line of sight over the bow, maybe factoring in the yacht's superstructure, it might be useless when you actually need to see something close up in the water.
So this isn't a DIY job or something for just any marine electrician. You need specialized expertise.
Yes, exactly. It really requires professional installation. And that process starts before drilling any holes. It starts with custom system design, really analyzing the specific vessel, how it's used, its blind spots, its operational needs. The experts mentioned, like Concord Marine Electronics, use NMEA certified engineers. NMEA is the National Marine Electronics Association. They set the industry standard for installation quality and network integration.
Okay.
These specialists handle the precision work, getting the alignment perfect, ensuring it's properly waterproofed, and doing that critical network integration, connecting it correctly with the radar, the autopilot, the main displays. That integration is key. It means, for example, that if your radar gets a faint, uncertain ping, you can have the system automatically slew the thermal camera right to that bearing for instant visual confirmation. Is it a wave? Is it a container? Is it a small boat?
Right. Without that professional touch, you just end up with a very expensive standalone gadget that isn't reaching its potential. Well, that definitely brings us full circle then. We started with that really bold claim. Flir Thermal is the single most valuable safety upgrade a captain can add. And I think our deep dive confirms why they say that. The investment delivers this unparalleled early detection obstacles people. It fundamentally changes night navigation, turning it from reactive hoping into proactive safety management. The cold insight really seems to be that true mastery and control at sea starts with having that 24/7 all-weather awareness. And thermal is seemingly the only visual system that works reliably when everything else, your eyes, sometimes even radar, fails you.
Yeah, that superior clarity just eliminates so much uncertainty. It empowers the captain and the whole bridge team to make those split-second confident calls. You can almost say it's the commitment to safety itself, just distilled into a piece of technology.
Okay, that wraps up our analysis.
Which leads us to our final provocative thought for you, the listener, to maybe mull over. If thermal vision represents this commitment to safety and mastery at sea, moving from being an optional extra to basically a non-negotiable standard for professional captains, what other technologies that maybe seem advanced or high-end today across any field or industry, what else might be on the cusp of transitioning from a luxury feature into being the absolute everyday expected standard for delivering certainty and control? Something to think about.